Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be talking about how to calculate the number of atoms that are present in a certain length of a certain gauge wire. So again, this is an example problem or practice problem in which you can use your skills of using conversion factors to help you solve a problem. So let's get into this. So here we're asked, how many atoms of copper are present in a copper wire that is 1.00 meters in length, and it's got 12 gauge. It's a 12 gauge copper wire. So in order to help us do this conversion, there's a few things we need to know. First, we need to know that the 20 gauge wire, 20 gauge means that you've got a diameter of 0.03196 inches. The density of copper is 8.92 grams per centimeter cubed, and the mass of a copper atom is 63.55 AMUs. So how can we use this information to help us calculate the atoms? Okay, so all of this information that we're given is going to help us do conversion factors. So first we got the mass of one atom in AMUs, and we can remember, well, the mass of an atom in AMU is going to be the same number in grams of 1 mole of that substance, or 1 mole of atoms. So that's called the molar mass. So if we're given the atomic mass or the molecular mass, we can easily change that to molar mass by keeping the number and just understanding that that's going to be the same number of grams for 1 mole of that substance. So if we know that one atom of copper is 63.55 AMUs, then we also know that 1 mole of copper atoms is going to be 63.55 grams. So we can use that. So 1 mole of copper atoms is equal to 63.55 grams. And we should remember that 1 mole of particles is equal to 6.022 times 10 to the 23rd particles. Right? In this case, we're talking about atoms of copper. Okay, so that's one thing. Another thing was there were given density, so we can use that to convert between grams of copper and the volume of copper in centimeters cubed. And so that's some stuff we can use. Now, thing you want to keep in mind is that, okay, we got this copper wire. It would be helpful to treat this wire as a cylinder, right? Because wires are cylindrical, they're round shaped, they've got a length. So if you were to like kind of zoom in on the wire, it would look like a long cylinder of copper. So if we want to find the atoms in the length of wire, it would be helpful to be able to get the volume of that copper wire. And the way we can do that is just treat it like a cylinder. So what's the formula for the volume of a cylinder? That's going to be volume is equal to the area multiplied by the length. And the area of the cylinder, if you looked at straight on, it would be a circle. So what's the area of a circle? Pi r squared. So pi radius squared multiplied by the length. Okay, so all we need to do is find the radius and the length and multiply those. And to get the volume, we would need to get volume in centimeters cubed. Why would centimeters cubed be what we would want? Because we got centimeters cubed here. So if we could get centimeters cubed, then we could use this to convert centimeters cubed to grams. And then we could use molar mass to convert grams to moles, and so on. Okay, so first things first. So we need to calculate the volume. We we need the area, or we need pi r squared. So we need to get the radius squared in centimeters. Here we're given the diameter of 0.03196 inches. We need to convert that to centimeters, and we need to convert diameter to radius. We know that one diameter is equal to the radius times 2. It's double the radius. So we divide the diameter by 2 to get the radius. Okay, so what am I going to do first? I'm going to convert to centimeters. So I'm going to first take the diameter. So the diameter, I'll do that over here. So that I'm going to take 0.03196 inches. And I'm going to use the conversion factor of 1 inch is equal to 2.54 centimeters to convert to centimeters. Okay, so I have 1 inch on the bottom, and I have 2.54 centimeters on top. Inches are going to cancel out. Now I have centimeters, and when I calculate this out, I get, hold on a second, 0.0811784. Okay, so 81170. Okay, so here I'm going to put it down here. So that's equal to 0.0811. Where is it? 784 centimeters. 784 centimeters. Now, according to sig figs, here I have 4 sig figs. Here I have 3. So again, the rule is if you're multiplying and dividing, then your answer should have the same number of sig figs as the least number. The least number here is 3, so I'm going to do 1, 2, 3. So, but I do need this number later on, so I'm going to keep the rest of digits. You actually should keep 1. 1 is enough. So that's kind of the rule of thumb, is if you, whatever number of sig figs you have, keep 1 extra digit to avoid the rounding error, because if you're going to use this later in further calculations, which we're going to do here. So now I have this, and now this is the diameter in centimeters. I'm going to divide this by 2, right? So if I have 0.0811784, oops, wrong one. So the second one is the last significant figure. I'm going to divide this by 2. And since 2 is an exact number, that's not going to affect the sig figs. So I'm still going to have 3 sig figs. And then when I do that, I get, what's the diameter? I get 0.0485. I'm sorry, 405. So 0.0405. And what's the next digit? 892. 892. Oops, that's an ugly. 892. And again, since this has 3 sig figs, then 1, 2, 3, that's going to be 3 sig figs. You can keep up to the 8, right? 8. You can keep 92, it doesn't matter, but really you don't need the 92. You could just keep the 8. That should be enough to avoid rounding errors. Okay, so this is in centimeters, and this is equal to r, the radius. So I found the radius in centimeters. Now the length is 1 meter. I need to convert that to centimeters as well. But 1.00 meter, 1 meter is equal to 100 centimeters, right? We could do the conversion factor. So 1.00 meters over 1 And I know that one meter is equal to 100 centimeters, or 1 centimeter is equal to 1/100th of a meter, right? So I could do that. So I have meters on the top. So I would have 0 or 10 to the negative 2 meters, or 1/100th of a meter is equal to 1 centimeter. Meters cancels out. And when I divide, I get 100 centimeters. Again, my answer should have the same number of sig figs as the least number of sig figs in the measurement that I'm multiplying and dividing by, because I'm multiplying and dividing. That's the rule. So here, this is exact, so I can ignore that. Here I have 3 sig figs, so I should have 3 sig figs here. That's the reason why I have the decimal point. If I don't have the decimal point there, that's only 1 sig fig. But if I have the decimal point, these zeros are now significant, and so that's going to be 3 sig figs. So I have 3 sig figs here. So now I have the length in centimeters. I have the radius in centimeters. So now I can plug that into the equation. So that's going to be equal to pi times r squared, which is going to be 0.04058. I'll stop at the 8. So remember, the 5 is my last significant digit. And this is going to be squared, multiplied by the length, which is 100. So 100 centimeters. And when I calculate that out, I get a volume of 0.5175, 0.5175. I got more digits here. 517572 centimeters cubed. Again, this has 3 sig figs, this has 3 sig figs, so I should have 3 sig figs in my answer. So 1, 2, 3. So the 7 is my last sig fig. I still need to use this in further calculations, so I should keep at least 1 extra digit when I do my calculations. I'm not going to round here just yet. Okay, so now I have centimeters cubed. I got the volume. Now I can go ahead and do the conversion factors to convert my volume of my copper wire into number of atoms. Okay, so let's go ahead and do that. So I'm going to start down here. I have room down here. So I'm going to start with this number here. So I have 0.5175. I'll just put a line. I'm going to put a line under the 7 to remind me that I have 3 sig figs here, but I'm keeping an extra digit to avoid rounding mistakes. Rounding error. And this is centimeters cubed. So now I'm going to use centimeters cubed. I'm going to use the density as a conversion factor, centimeters cubed to grams. So I have centimeters cubed on the top here. So I'm going to put centimeters cubed on the bottom. So 1 centimeter cubed and then on the top I have grams, 8.92. So 8.92 grams. Oops, that should be centimeters cubed. So centimeters cubed cancels out. Now I have grams. So now I have grams of copper in my wire. I'm going to use the molar mass. Molar mass is 1 mole of copper atoms is equal to 63.55 grams. So since I have grams on top, I'm going to put grams on the bottom of my next conversion factor. So I'm going to put grams down here. So 63.55 grams. Okay. And just to be clear, we're talking about copper. So I'll put copper here and copper here. So we're just clear on what substance we're talking about. copper. So we got grams of copper, and that's going to be equal to 1 mole of copper atoms. So 1 mole of copper. So grams of copper cancel out. Now I have moles of copper, but the question is how many atoms of copper? So I want atoms of copper. Atoms are particles. So I'm going to use Avogadro's number. I'm going to use 1 mole is equal to 6.022 times 10 to the 23rd particles, or atoms in this case, to convert to number of atoms. And that's my last one. That's my last conversion. So since I have moles of copper here, I'm going to put moles of copper here. So 1 mole of copper atoms. So 1 mole of copper. And then on the top, I'm going to have 6.022 times 10 to the 23rd. So 6.022 times 10 to the 23rd atoms of copper, or copper atoms. So moles of copper cancel out. Now I have atoms of copper on top. That's exactly what the question is asking for. I am done. All I need to do now is multiply by everything on top, divide by everything on the bottom. And when I do that, I get my answer, which is, where's my answer? 4.37 times 10 to the, is it 20 seconds? To the 22nd atoms of copper, or copper atoms. So this is my answer. You'll notice I have 3 sig figs. Why do I have 3 sig figs? Because I have 3 sig figs here. I have 3 sig figs here. I have 4 here. I have 4 there. So the least number of sig figs is 3. So my answer should have 3 sig figs. And that's it for this video. I hope this video was helpful. If you enjoyed this video, if you learned anything from this video, then please like the video, share the video, hit that like button. Also, make sure you subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, or if you have a particular problem or a question you have that you need help with, put that down below. I would love to help you with that. Thanks for joining me, and have a great day.